The Luftwaffe intelligence summary that reached General Adolf Galland's Fighter Command headquarters in Berlin during January 1945 contained P-51 Mustang production statistics that seemed to mock the fundamental laws of aircraft manufacturing and aviation industrial capacity. The classified document claimed that American factories had produced over 70,000 P-51 Mustang fighters in just 3 years, suggesting production capabilities that violated every German assumption about precision fighter construction and wartime aviation manufacturing. This is mathematical absurdity disguised as intelligence, General Galland declared to his ace pilot staff, studying reconnaissance photographs of North American aviation plants that showed fighter assembly operations spanning multiple city blocks. Fighter aircraft are precision instruments requiring months of individual craftsmanship. No factory can manufacture 70,000 advanced fighters in 3 years. These Americans must be including prototype mock-ups and training airframes in their production statistics. These were legendary German fighter aces who understood aircraft production through decades of meticulous engineering and artisanal craftsmanship that had created the world's most sophisticated fighter aircraft through systematic precision and technological excellence. The concept of mass-produced advanced fighters seemed to violate fundamental principles of aviation manufacturing that demanded individual attention over assembly speed. They could not comprehend they were witnessing the greatest fighter production achievement in aviation history, or that American factories would demonstrate how democratic industrial organization could manufacture advanced aircraft at rates that would overwhelm German fighter excellence through unprecedented numerical superiority and continuous replacement capability that rendered individual pilot skill strategically irrelevant. If you want to discover more incredible stories of how American industrial supremacy revolutionized modern warfare, make sure to subscribe to our channel and hit that notification bell. General Adolf Galland stood beside his personal Messerschmitt Bf 109 at a forward airfield in France, embodying German confidence in fighter superiority through innovative aircraft design and systematic ace pilot development. As General der Jagdflieger, Galland represented German assumptions about fighter quality triumphing over quantity through superior technology, individual pilot excellence, and professional aviation standards that had established German aerial dominance across European skies. German fighter aircraft production that Galland understood included meticulous craftsmanship, individual attention to aerodynamic specifications, and systematic quality control that created superior combat aircraft through careful engineering and performance optimization. German factories produced fighters like precision scientific instruments rather than mass-manufactured products, emphasizing technological excellence over production volume through artisanal manufacturing approaches that prioritized individual aircraft perfection. The sophisticated fighters that German aviation employed included advanced Messerschmitt Bf 109s, revolutionary Focke-Wulf 1900s, and jet-powered Me 262s that represented pinnacle achievements in fighter engineering through systematic development and operational experience. German engineering had solved complex aerodynamic challenges that produced aircraft exceeding Allied capabilities through individual excellence and precision manufacturing that emphasized superior performance over numerical abundance. Intelligence analysis of Allied fighter production suggested enemy forces remained constrained by conventional manufacturing limitations, precision engineering requirements, and industrial bottlenecks that prevented rapid advanced fighter expansion. German aviation planners calculated that Allied fighter production would require decades to match German technological capabilities while maintaining acceptable combat performance standards through traditional manufacturing methods. Strategic doctrine that incorporated German fighter advantages, assumed technological superiority, would enable continued aerial dominance through superior aircraft performance and systematic ace pilot training. Democratic air forces could allegedly never achieve rapid expansion and quantity-focused production approaches, while maintaining individual fighter excellence that characterized German aviation superiority through precision engineering and professional pilot development. Economic calculations performed by German aviation economists revealed Allied industrial capacity divided between civilian aircraft production and limited military requirements, suggesting resource constraints that prevented total conversion to advanced fighter manufacturing. Aluminum allocation and skilled aviation technicians appeared insufficient for massive fighter production programs, requiring specialized engineering and precision manufacturing techniques. Cultural assumptions about American fighter industrial organization suggested inefficient production methods and profit-motivated rather than strategically focused approaches that would prevent systematic advanced fighter manufacturing. German aviation ideology characterized democratic industry as wasteful and disorganized compared to German systematic efficiency and specialized fighter technological discipline that prioritized individual aircraft quality. Combat statistics from 1939 to 1943 seem to validate German assumptions about fighter warfare effectiveness and technological advantages over Allied aviation forces worldwide. German fighter units had achieved remarkable success through superior aircraft performance and systematic ace training that appeared impossible for mass-produced enemy fighters to match through quantity alone. Pilot training philosophy that German aviation emphasized included individual excellence development, combat experience accumulation, and systematic skill advancement that created ace pilots through rigorous selection and professional development. German fighter force prioritized quality over quantity in both aircraft and personnel, reflecting confidence that superior individual performance would achieve victory through technological and training advantages. James Howard Dutch Kindleberger, president of North American Aviation, walked through the sprawling Inglewood and Dallas manufacturing facilities, observing revolutionary production techniques that would transform fighter aircraft manufacturing through automotive mass production methods adapted for advanced aviation. The civilian aviation executive was applying innovative production expertise to sophisticated fighter construction with systematic efficiency that would fundamentally challenge German assumptions about advanced aircraft manufacturing. The P-51 Mustang program that American industry developed represented complete departure from traditional fighter manufacturing that emphasized individual craftsmanship over systematic mass production for advanced aviation. Mustang design prioritized aerodynamic excellence, combat effectiveness, and assembly line production capability rather than technological sophistication alone, enabling manufacturing rates that completely exceeded German fighter industrial calculations and strategic planning assumptions. Assembly line techniques that North American aviation employed included revolutionary automotive production methods, systematically adapted for complex fighter manufacturing through organized workflow, standardized components, and continuous production that eliminated traditional advanced aircraft manufacturing bottlenecks. American industrial experience had created unprecedented manufacturing efficiency that surpassed specialized fighter production through civilian innovation and competitive optimization applied to sophisticated aviation. Workforce mobilization supporting Mustang production included revolutionary numbers of women entering precision manufacturing while maintaining comprehensive training programs that created skilled workers adequate for complex fighter assembly operations. Democratic educational systems produced abundant human resources through competitive instruction, merit-based advancement, and systematic advanced aviation manufacturing skills, development that exceeded traditional fighter production workforce limitations. Supply chain coordination across American Mustang manufacturing included specialized aluminum delivery from multiple continental sources, Rolls-Royce Merlin engines from Packard manufacturers, and thousands of precision components from hundreds of subcontractors whose production was synchronized through systematic logistics management. Materials coordination exceeded German organizational capabilities through democratic industrial cooperation and competitive resource allocation that enabled unprecedented advanced fighter production rates. Quality control procedures ensured Mustang reliability through systematic testing protocols, continuous inspection processes, and rigorous combat performance validation that maintained fighter effectiveness while enabling unprecedented mass production rates. American fighter manufacturing had achieved consistent quality through scientific methods rather than traditional individual craftsmanship attention, proving that systematic approaches could maintain advanced aviation standards while enabling mass production. Innovation acceleration continued throughout Mustang development as American engineers continuously improved fighter specifications while maintaining aggressive production schedules that traditional methods could never sustain. Competitive pressure encouraged rapid advancement that exceeded conventional fighter development cycles while ensuring manufacturing compatibility and sustained production capability that traditional approaches could never achieve through individual craftsmanship methods. Strategic planning that incorporated massive Mustang deployment included comprehensive fighter tactical doctrine development and operational coordination that would maximize aircraft effectiveness across global theaters. American military aviation strategy integrated production advantages into comprehensive campaign planning that assumed virtually unlimited fighter availability and continuous replacement capability that would fundamentally alter aerial warfare mathematics through industrial superiority. Engineering excellence that Mustang production achieved included aerodynamic optimization, engine integration, and combat effectiveness that exceeded traditional fighter development while maintaining mass production compatibility. American aviation had proven that systematic manufacturing could produce advanced fighters without sacrificing performance, demonstrating democratic advantages in combining technological excellence with industrial abundance through competitive innovation and systematic engineering approaches. March 1944. German intelligence documentation of American Mustang production revealed manufacturing statistics that challenged every fundamental assumption about advanced fighter construction and aviation. Industrial possibility worldwide. American factories were completing over 600 P-51 Mustangs monthly, while maintaining simultaneous production across multiple facilities that collectively exceeded total German fighter manufacturing capacity by incomprehensible margins that seemed mathematically impossible for advanced aircraft. Mathematical analysis that German fighter planners performed revealed American Mustang production approaching 70,000 total units in 3 years, while German advanced fighter production struggled to maintain 25,000 aircraft across all manufacturers and facilities. Enemy industrial capabilities had achieved systematic abundance that completely violated traditional assumptions about precision fighter manufacturing, complexity, and specialized engineering requirements that German aviation had always considered fundamental limitations for advanced aircraft production. Statistical verification through multiple intelligence sources confirmed American Mustang production that included standardized components, revolutionary assembly line manufacturing, and systematic quality control that enabled mathematically impossible production rates for advanced fighters. Enemy manufacturing had achieved unprecedented efficiency that exceeded German fighter industrial organization through democratic competitive methods and civilian automotive expertise applied to sophisticated aviation manufacturing. Photographic reconnaissance of American fighter factories revealed production techniques that completely eliminated individual aircraft craftsmanship in favor of systematic manufacturing approaches directly adapted from civilian automotive industry methods for advanced fighter applications. Democratic industrial organization had achieved military production through competitive, rather than centralized authoritarian methods and systematic resource optimization that exceeded traditional advanced fighter manufacturing approaches. Economic calculations demonstrated American Mustang expenditure that exceeded entire German aviation budgets while simultaneously maintaining civilian automotive production and comprehensive international assistance programs. Democratic capitalism had achieved resource abundance that centralized command economy methods could never duplicate through systematic efficiency and competitive innovation in advanced fighter manufacturing that rendered German economic assumptions obsolete through mathematical evidence. Supply chain analysis revealed American Mustang manufacturing coordinated across continental distances with material flows that dramatically exceeded German logistical capabilities and organizational systems. Enemy industrial organization demonstrated systematic coordination that exceeded authoritarian central planning through competitive cooperation and democratic resource allocation methods in advanced fighter production that achieved efficiency through civilian expertise rather than military organization. Technology assessment based on captured American Mustangs revealed manufacturing quality that equaled German precision standards, while being produced in quantities that German industry considered physically impossible without sacrificing combat performance specifications. Mass production had achieved consistent reliability through systematic scientific methods, rather than individual attention and artisanal approaches that characterized German advanced fighter manufacturing philosophy. Performance analysis of combat-recovered Mustangs demonstrated that American mass production had achieved aerodynamic excellence, engine optimization, and combat effectiveness that matched or exceeded German individual fighters while being manufactured at impossible scales. Systematic engineering had proven superior to traditional craftsmanship in producing advanced fighters through competitive innovation and scientific manufacturing approaches. The statistical impossibility had become undeniable strategic reality that forced German acknowledgement of democratic advantages in advanced fighter industrial organization that exceeded authoritarian alternatives through competitive efficiency and systematic abundance in sophisticated aircraft production that would fundamentally alter aerial warfare through industrial superiority rather than individual technological excellence or traditional aviation approaches. January 1944. The first massive Mustang formations appearing over German airspace revealed devastating effectiveness of American fighter production, as over 800 P-51s provided escort for bomber raids while maintaining strategic reserves that exceeded German total fighter inventory. The mathematical superiority of American manufacturing had translated into overwhelming aerial dominance that rendered German fighter philosophy strategically obsolete through systematic abundance rather than individual aircraft excellence. Tactical deployment that American Mustang abundance enabled included multiple fighter groups operating simultaneously across European airspace while maintaining escort capabilities that German interceptors could never overcome despite individual aircraft superiority and ace pilot advantages. American production had eliminated traditional fighter constraints through systematic abundance and continuous replacement that exceeded conventional aerial warfare limitations through industrial capacity. German fighter pilots discovered combat situations where shooting down individual Mustangs achieved minimal strategic impact because American formation strength exceeded German interception capabilities through numerical abundance. Mathematical relationships had shifted decisively toward Allied aviation through manufacturing capacity rather than individual combat effectiveness or pilot excellence that had characterized traditional fighter warfare approaches throughout aviation history. Combat statistics from sustained European air operations documented German fighter losses that could not be replaced, while American Mustang units maintained operational strength through continuous production and systematic pilot replacement programs. Industrial abundance had created tactical sustainability that exceeded German response possibilities and resource allocation capabilities through democratic aviation organization rather than traditional fighter force approaches. Intelligence analysis by German fighter commands revealed American production capabilities that dramatically exceeded strategic planning assumptions while demonstrating aviation organization that surpassed authoritarian efficiency through democratic competitive methods. Enemy capabilities had achieved systematic advantages that traditional military aviation could not anticipate or counter effectively through conventional fighter tactics or resource allocation methods. Psychological impact on German fighter pilots included recognition that individual combat excellence could not influence strategic outcomes when facing opponents with unlimited replacement capabilities and continuous reinforcement deployment. Tactical victory had become strategically meaningless against American production abundance and systematic fighter deployment that exceeded traditional aerial warfare mathematics through industrial superiority. Operational advantages that American Mustang production provided included aircraft availability, pilot replacement, and sustained mission capability that maintained escort effectiveness under extended campaigns across multiple theaters. Systematic operations exceeded German capabilities despite homeland air defense advantages and theoretically superior interior coordination lines through democratic industrial organization. Range capabilities that Mustang abundance enabled included deep penetration escort missions, sustained patrol operations, and continuous air superiority maintenance that German fighters could never counter through individual excellence. American production had created operational reach that exceeded traditional fighter limitations through systematic abundance and technological integration. The Mustang swarms over Germany demonstrated American fighter production had fundamentally altered aerial warfare mathematics through manufacturing capabilities that rendered traditional fighter excellence obsolete when facing systematic abundance, combined with adequate performance and continuous replacement capability that exceeded conventional aviation limitations through democratic industrial superiority. May 8, 1945. As Nazi Germany surrendered unconditionally following complete Allied air superiority, the final accounting of American Mustang production revealed numbers that had redefined fighter aviation. Over 70,000 P-51 Mustangs, manufactured through revolutionary assembly line methods that averaged 65 completed fighters daily at peak production, creating aerial capabilities that had overwhelmed German fighter excellence through unprecedented systematic abundance and continuous replacement. Strategic validation that American Mustang production provided confirmed industrial mobilization as the decisive factor in modern fighter warfare while demonstrating democratic advantages in manufacturing organization, resource allocation, and technological application that exceeded totalitarian alternatives through competitive innovation and systematic efficiency optimization. Democratic fighter industrial organization had proven superior to authoritarian approaches through mathematical evidence that could not be disputed. General Gallen's post-war acknowledgement included recognition that German fighter superiority had been strategically defeated by American production capabilities that exceeded every calculation of democratic industrial potential and advanced fighter manufacturing capacity. Assembly line manufacturing had rendered individual fighter excellence and ace pilot skills strategically irrelevant through overwhelming numerical superiority and coordinated operational deployment that exceeded traditional aviation warfare approaches. Economic efficiency that American Mustang production achieved included dramatic cost reduction through volume manufacturing, while maintaining combat effectiveness that exceeded traditional fighter development methods. Competitive capitalism had proven systematically superior to command economy organization for sustained advanced fighter production and technological advancement across global aviation operations through democratic resource allocation and competitive innovation processes. International cooperation through American Mustang deployment included comprehensive fighter transfers to Allied air forces that enhanced collective aerial capabilities while demonstrating American production capacity far beyond domestic requirements. Democratic values had created sustainable assistance through systematic fighter sharing and strategic generosity programs that exceeded traditional military alliance approaches through competitive manufacturing and resource abundance. Technological legacy of American Mustang production influenced post-war fighter aviation through revolutionary manufacturing techniques, systematic design principles, and scientific quality control methods that transformed global advanced fighter production standards. Scientific advancement had created lasting advantages through systematic research and competitive innovation processes that exceeded traditional fighter approaches through civilian automotive expertise applied to sophisticated aviation. Pilot training systems that Mustang abundance enabled included accelerated instruction programs, advanced aircraft availability for training, and systematic pilot development that created human resources adequate for expanded fighter capabilities. American aviation education had produced pilot resources through competitive instruction and merit-based advancement that exceeded traditional ACE development approaches. Operational development that enabled American Mustang success demonstrated democratic society's ability to coordinate massive advanced fighter resources through systematic planning and competitive efficiency rather than authoritarian control. Democratic systems had produced sophisticated fighter capabilities that exceeded totalitarian alternatives through systematic coordination, competitive innovation, and merit-based operational advancement that proved democratic advantages. The assembly line triumph had proven that democratic industrial organization could achieve systematic advantages over traditional fighter excellence through competitive innovation, systematic manufacturing, and abundant production that totalitarian aviation systems could never match through centralized control, individual craftsmanship, or authoritarian resource allocation alone in advanced fighter manufacturing and aerial warfare. If this incredible story of how American assembly line Mustang production overwhelmed German fighter excellence through systematic abundance amazed you, make sure to subscribe for more tales of democratic aviation triumph.